In 2019, a team of scientists published their analysis of a vast radio-emitting filament of plasma, which stretches across 10 million light-years, connecting two clusters of galaxies, called Abell 399 and Abell 401. The filament, which a scientist discovered using a low-frequency radio telescope called LOFAR, also marked the first time scientists have found a magnetic field connecting two galactic clusters. The radio emission from the filament is called synchrotron radiation, which is produced by the tremendous acceleration of electrons along the filament at relativistic velocities. As stated by astronomer Matteo Murgia, we typically observe this emission mechanism in action in individual galaxies and even in galaxy clusters, but never before has a radio emission been observed connecting two of these systems. A ScienceAlert.com report on the discovery states, "The electrons are covering way more distance than is expected, which means there has to be another element at play." In the aforementioned Quanta Magazine piece, the description of the radio-emitting magnetic filament inadvertently confirms the electrical interpretation. The article states that the scientists, quote, "inferred the presence of a magnetic field in the filament between galaxy clusters Abell 399 and Abell 401 from the way the field redirects high-speed electrons and other charged particles passing through it. As their paths twist in the field, these charged particles release faint synchrotron radiation. However, the scientists seem not to recognize what this must mean. The release of, quote, faint synchrotron radiation means the charged particles are losing energy, and thus they cannot continue to radiate over cosmic distances unless they are continually receiving electrical energy, which constitutes an electric current." We note that as far back as 1992, Dr. Anthony Peratt of Los Alamos Laboratories, himself a student of Hannes Alfvén, discussed the evidence for, quote, supercluster scale electric currents in his textbook Physics of the Plasma Universe. In the chapter titled Currents in the Intergalactic Medium, Peratt writes, "One of the most compelling pieces of evidence for the existence of supercluster-sized currents comes from the discovery of faint supercluster-scale radio emissions at 326 MHz between the Coma cluster of galaxies and the Abell 1367 cluster. In Peratt's view, these intergalactic currents are spiraling Birkeland currents, which will accelerate charged particles in circles, which is to say orthogonal to the current's direction, which must then generate synchrotron radiation.